Hello everyone, welcome back. My name is Rafael Escala. Thank you for watching this video. Today we will continue doing a video series talking about the design data intensive application ebook. This is the early access, the 2026 edition, and we will discuss the distributed system. Okay, so distributed system is when there are multiple nodes or machines that is there is a communication between of them using a networking, right? And it's important that there are multiple advantage if you want to use a distributed system, but obviously there are against. Okay, but take a note that it for you the advantage is better for your software solution. You can use it. Okay, so it's not only the best solution for all the application that you wanted to use. Okay, so there are some, I take note some of reason that maybe it could be a good idea to implement that. Okay, so for example, you have a large volume of data and need to be processed with a machine learning or the analytical system. So in that case, maybe it's better to have a distributed system to only have the large volume in some place, in another place to process them, right? So we know that they can know that it will have a worse performance because you need to transfer all the data using the networking, right? But imagine that if you are working with machine learning, you have to have a machine that support uh, more GPU. In that case, maybe it's very easier to scale vertically for a specialized hardware, right? And data storage could be maybe focused to only increment a part of the disk, right? So in that cases, it is you need to handle it multiple distributed system because you need to transfer the data to another hardware that have more power to process them, right? So another reason to handle distributed system is when you want to have a full tolerance or high availability. That means when you need to have a redundancy of the data, for example, or the application that you want to support a full tolerance. Imagine that if you have an application or a node that is crashed or is down, okay, but you already implemented a redundancy or replication of that application, for the final user is not have an impact because it will connect with another node that is already is available. So that means that your application have a high availability because you have a high tolerance if there is a part of your system that it could be down, right? So that's I mean, and when we are talking about scalability, well, there are multiple ways to create this scalability. If you were talking about, for example, data, you can create a shared of of the storage that you have, and maybe you can create multiple nodes that maintain the storage spread or split it in multiple shards, right? So imagine that is instead to have a single data storage, it could be split in multiple shards, and obviously there is an against to decide to do with this because it will be difficult to um, merge all the data that maybe you can have because it will spread in multiple nodes, but it will increment the performance. So this is an advantage, okay? But if you, for example, you want to have an scalability or using um, a load balancer, right? You maybe need to do a distributed system to replicate your application to support maybe more mm, throughput, right? And that's all, right? When you are talking about the latency, when is that you want to create a better performance because you have an audience that is distributed geographically, right? So maybe you need to have a strategy to handle it. This audience and need to be replicated the data or the node or the application in multiple regions of the world, right? So for the user, it will have a better experience if the data is very close of his location. So for that reason, latency could be incremented if you have a distributed system in multiple regions, right? That's it. The elasticity, it means when you not need to spend money to have a server that is idle, because if you have a replication of if you replicated your application in multiple nodes, you have the ability to down some server that is not need to be used because you have in some moment of the day the traffic is not uh, there is not a peak of traffic. So in that case, maybe you need to down some servers. In that cases, we are talking about distributed system because you have multiple nodes with a set application, but you can down or you can up um, replications depending of the requirement and that moment you need, right? And well, we're talking about maybe illegal if you need to distribute the storage in multiple countries because there is a regulation or jurisdiction, right? To have a requirement that and the country you have to store the data in that place because there isn't something legal, right? So that is important to use this distributed system, okay, in that scenarios. And take a note that not all is a positive. There is a challenge that you have to challenge, you have to handle it when you decided to go to the path of the distributed system. That is that for each network communication, you have to support a point of failure because there is a possibility that there will be a node or server that could be down or crashed, and or there is an overloaded of the server. So in that case, you have to use some strategy in your architecture of your application to have a high tolerance. Maybe only to say something, maybe you have to implement a circuit break pattern, or maybe use handle using events to be a synchronous process, right? And in working with a eventual consistency, right? So that is an idea to have to support that, right? Or out-of-box patterns. So that's it, okay, in summary. And there is another challenge that is when the latency of the transfer data is. Take a note that when you transfer the data, there is a latency. So the idea is to have your nodes very close of them in that same region, only to have an example, but actually always it will be a latency because if you are working with large volume, maybe you need to create chunks of the data, right? To spread the data and work with in parallel. So you have to take note about that. And if you are working with distributed system, maybe a problem when you are trying to generate an observability or monitoring of this nodes or application, and finally, the reason it will generate a problem to diagnosing, right? When you are trying to understand in which part of the distributed system is having a bad performance, or there is a problem and you have to deep in the trace, maybe using OpenTelemetry to finally realize it in which part of the distributed system there is a bug, right? So that is a problem that it could um, have to handle it the developer, right? In that case, and you have to take note that you will have to working with consistent of the data because when we are talking about distributed systems, we have to think that is isolated the data. It's like each responsibility of the server, the responsibility of the server had to be isolated and it had to be independency. So the independence, when we're talking independency of the data of the server, also needs to be the isolated data. So if you are trying to work in asynchronous in multiple servers, have to be synchronized between of them. But that maybe I can explain more with when we are talking about the microservice, because microservice isn't a concept, right? When you are working with isolated teams, isolated application, right? And there are multiple in this distributed architectural, there are multiple ways to communicate of multiple servers. That in this case, maybe you can decide to use or you can take the decision to use the server-oriented architecture, as the SOI, is when you are working with API REST to communicate between servers, or if you want to working with event-driven architecture, is when you working you communicate between multiple servers using only backbone of events. There's not a HTTP request between of them. The idea to event driven is to not overload the networking. Calling directly is like a process with a broker of events and how to handle it asynchronous. But when you are working with event driven, you have to take a note that eventually there will be synchronized in some moment. So it's basically working with asynchronous, right? That's it. And like I said before, microservice, the idea to be is isolated servers, updated independently. Each server had to have own database or infrastructure. So when you're talking about infrastructure, because you have to maintain a different kind of machines, right? You have to support monitoring of each microservice. You have to support the trace, the pipelines of the build of the application, right? Everything of the flow that you introduce when you are working on an application, it will apply for each microservice. So that is a challenge that you have to use. And okay, so there is an isolated release that I say before. The teams in the idea to be independently, right? You are working with squads. So if you not need to have the advantage of taken before, maybe you are talking about if you have a large number of the workers in your company and need to not everybody have to work in the same I don't know source of code. Maybe you need to split your application in multiple servers because you want to have a squad of teams and not generate a conflict of chains because they are working in the same application, right? So that is another reason, but there will be another challenge that it will very complicated if you want to do an end-to-end testing, because you need to um, deploy multiple servers to reproduce a case and edge case maybe, right? So that may be the complex part, because an edge case in edge case it will appear with multiple servers running and you are testing a single flow, right? So that is another thing that you have to take a note. And well, there's another solution that is the serverless when you are working with cloud, but it's not. It's you have to not confuse with the serverless, because actually exist the servers, but it's managed by the cloud, and the scalability of of these servers is it will handle the cloud too, right? So only to focus on to create the logic that you wanted, you only using a function, right? And it's called using APIs, and you only pay per use. So there is, if there is any traffic calling this function with serverless, you don't pay nothing. So that is advantage if you don't you have you have a functionality that is not called several times, maybe serverless is a good approach, right? And take a note that there's an advantage is that you have to handle the slow start time. There isn't a trick to uh, maybe creating a pool to always be active the serverless, right? But yeah, when you're not calling and a time this serverless of function needs a time to be ready to run the function that you need to do, or the job that you're trying to use, right? And another thing that there is another way to use, well, another server that maybe you can use is the high performance computing, is also called it like a supercomputing, right? And in that case, it's when you need to a machine that need to do an intensive computing, scientific reason, maybe weather model, machine learning with super um, super complex calculation, right? And usually it's working like using large batch jobs, asynchronous jobs or processing with checkpoints. The idea to use checkpoint if there is um, in some moment there is that the server is crashed, when it's you can when you restart the node or the server is not to be, if there isn't a checkpoint that could recover and continue doing the job, right, that is doing before. So that's it. When there isn't a troubleshooting, you can use you can take note that you have to stop the entire cluster of the workload, repair if there isn't something that is not working, and restart again the pipeline. So that is the troubleshooting usually in this super computing. Obviously, if you compare it with the regular microservices or server that you are working with cloud or anything, the solution is usually is not stop. Actually, is down and recreate everything when you already fix in the application side, right? But in the case of the supercomputing, it's not need to be um uh, down the server, is only stop that. You have to for supercomputed servers, the connection of the user is 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 had to be trustworthy, because there is not authentication in this case. The idea is to only be used by person that have the responsibility to use these servers. Okay, and the idea of this one is the difference of the distributed system that could have multiple regions and other else. In this case, all the nodes have to be closer together to be faster any data transfer that exists in that case, right? So in summary, that's it. That is a distributed system. And thank you for watching the video again. And well, see you later. Okay, bye bye.